Listening at home, sorry you missed the first half of the lesson. Okay, so here we go. Sorry, Pete. Okay. Oh, gee. I need to make some room for this. Okay. Let's try the second one, which is a little bit harder. So sketch the region here. Y equals x squared is pretty straightforward. Negative x plus 6. What kind of graph is that? A line with what characteristics? What? Y-intercept is 0, 6 and goes down 1 over 1. So where would it hit the x-axis, which will be important in a minute? Would it also hit the x-axis? Yeah? Okay, so we have regions all over the place. Certainly if you misidentify the region, you're going to get the wrong volume. So read carefully. What's the region we're concerned about? Or concerned with? Is it the parabola line region enclosed, or is it the quasi-triangular region over at the right? F, G, and the x-axis. So what region is closed by F, G, and the x-axis? Yeah, it's the triangular region. If they said enclosed by F and G, then which region would you be talking about? Well, then you're talking about that one, okay? So read very carefully. If I revolve that around the x-axis, then I'll get kind of that same diamondy, I'll start to get a diamond shape. And let me draw a figure or two to give it some dimension. What do you see as a gotcha to this problem, or makes it harder than the other one? It's 2. Yeah, it's 2. If we were doing area on that region, we would need 2 integrals because there are 2 upper curves. And we have a transition from the parabola into the line. Well, the same is going to go with volume. There are 2 regions. And so I have 2 volumes. I'll need to find both. The first region will be pi r squared h, and the next region will be pi r squared h. Let's talk the first region. From where to where? Now, the intersection point is certainly where the end of the region is. I don't care if you show me all the algebra, you can just guess and check. Can you just tell me what the intersection x is? Because you're smart enough to just see it. 2. Yeah, it's 2. Yeah. Check it to verify 4 and 4. They do intersect when x is 2. So the first region is from 0 to 2. And what's the integrand? Now you could show the intersection, and you could show the algebra, and that's fine. I'm just trying to save some time here. What's the integrand for that first region? X squared, and the heights, they are dx. Now, that's probably a non-issue to you because that's all we've done so far. But in a minute, you'll have lots of choices for dx, dy. So it is important that you think that. The next region is from 2 to 6 and negative x plus 6 squared, quantity squared, d x again. At this point, let's use our calculator. There is one most common error that points are lost on the free response, and that is failure to remember the pi. That is the biggest error by far. That error is made because people say, oh, I'll do the integral, then multiply by pi. And they don't. So what's the solution to that? Don't do the integral, then multiply by pi. Do it all at once. And I mean all of it at once. You will not forget the pi. You will not forget the other integral. Your mistakes will be minimized. If you want to do some simplifying, for example, like x to the 4th, and that first one, that's fine. Don't forget both pi's. Okay, what do you have? Something like 87.1268? Yes? Okay. All right. So that's the first introduction to the idea around the x-axis, and we use cylinders. Now go to the back and let's talk. We did a little different axis of revolution. Say you had this square region, but read carefully here. Now we're talking the y-axis at y equals 3. So we're looking at this region here. Not adjoining the x-axis, but adjoining the y-axis. It's revolved around the y-axis, and so if you reflect it, it would look like that, and give it some dimension, it would look a bit like a funnel. All right, now, I told you that the axis of the slices should be done perpendicular to the axis of revolution. I'll talk about why that always is a little later on once we get good here. But if this is the axis of revolution run vertically, then the slices need to be run horizontally. These are my slices, and when they're revolved, then I'll start to get cylinders running that way. Thousands of them, millions of them. Now, in that case, then, the volume is still going to be the sum of many cylinders. So it's still pi r squared h. That is the big idea that governs all. But the details are different. Instead of the height being a small change horizontally, now the height is a small change vertically. And so now you're talking a height of dy. The function, and I think you'll also agree that each time I do these radius, this radius might be 2, and this radius might be 3, and this radius might be 9. All those radii are constantly the x. But I can't put an x here and square it, as much as that would make sense, because y is the variable of integration. So it needs to be x and y terms, so you're going to need to find the x in y terms, because we're integrating with respect to y. So this will be the function, well actually it runs to the inverse function really, but the function in y terms. The radius is still squared. Now because it's all with respect to y, it'll need to be low to high for the limits of integration rather than left to right. So if we were to set this volume calculation up, pi squared d, now because it's around the y-axis, it's dy is the height. How about the function? What goes in here? It was y equals the square root of x. But I need to figure out the radius is x, and so I need to solve that and put it in y terms. So x is x squared. So this will actually be, rather than the root of x squared, it'll be y squared squared, which is equivalent to the root of x. And the limits of integration, 0 to 9 or 0 to 3? 0 to 3, because it's a y variable, we need the y limits of integration. Okay? How many of these do I have? Okay. Try starting this one on your own, and you might run into a few questions as you go, but we'll talk about those once you get there. Go ahead and start. Remember, I want the solid of revolution, but then also a slice revolved to show the actual cylinder we're using to estimate that region, or one of the cylinders. Okay. Might be coming to a few gotchas, so let me just talk while you're working here. First of all, I don't see a y in there, but that's easily solved. Y can be f of x, and that's fine. So that's not much, right? Second issue is that when you go to solve this for x, what's x? Plus or minus square root of 4 minus y, right? So then that begs the obvious question, which one do I use? Which one do I use? Why doesn't it matter?
Because it's going to be the same on the top and bottom.
Yeah, look at this on two levels. First of all, graphically. If I did x as positive, then I'm only looking at the positive side of the parabola. If I revolve that, wouldn't I get the whole figure? Okay. What if I had used the negative side, though? If I revolve that, won't I still get the same figure? So that's not going to change. Now look at analytically, equation-wise. Whether I have a positive and negative here, will it matter? Well, no, by virtue of the square, it will matter anyway. So it doesn't matter if you choose plus or minus. Last of all, the limits. Will they matter? Will plus or minus matter for the limits? Yes? No? You'll get a lot more out of this class if you think and participate. Will the limits of integration matter whether I use plus or minus? Why not? Yeah, either way, for either region, the y limits are 0 to 4. We don't use the x. So either way, it'll all come out exactly the same. And that actually doesn't even really need, need a calculator for that. It's integrating 4y, or 4y minus 1/2 y squared, from 0 to 4 times pi. So that's pretty doggone easy. Something like 16 minus 16 halves. So, gosh, something like 8 pi. Wait. Okay. In the interest of time, I'm going to skip. I'll set this one up. We'll talk about this, but then we'll skip forward here. Say I had y equals x squared, negative x plus 6, and the y-axis, first quadrant region. In that case, then, this would be this region revolved around the y-axis. What would we have to do? You need 2 integers. Okay? In the interest of time, let's move on to the last part. This is pretty common. This is not a kind of question that we had when I was growing up. This is pretty sweet. This is a very common question now on the AP test. They just love this kind of free response question. And if you haven't practiced it, it's not obvious. So, Anna's got this vase, and she's trying to estimate the volume. Okay? What she does is at several different heights, from 2, 4, 6, and 8, she measures the radius. I actually imagine she measured the circumference and then deduced the radius, but that's okay. Now, she uses then a Wright-Riemann sum with that data to estimate the volume of the vase, which is to say, from 0 to 2, she uses the right side, or 2, to draw the radius at. So she's going to use the radius at 2, like we would a rectangle, and then revolve it. Then, in the next region, from 2 to 4, she's going to use the right edge 4 and find the radius at that and revolve it. Then the radius at 6 and revolve it. And then finally the radius at 8. And revolve it. And those 4 cylinders then will estimate the volume. Now, we normally, or before today, we would do the volume, the area is roughly 4 rectangles. And depending on the table, sometimes we had a common base that we could factor out if the bases were all the same. Here, however, today, we're not using area and rectangles, we're using volume and cylinders. So it's going to be the volume of pi r squared h plus pi r squared h plus pi r squared h plus pi r squared h, 4 cylinders. Now in this case, are there common factors to take out? Pi is definite. Take pi out. What about the height? Are all the heights the same? They are. So we can take out a height. You could call it h, or at that point you could put in 2 if you like. Now, just like any table problem, before you go rushing into the table values, you need to communicate where you're coming from. If I'm using a right Riemann sum, then the first radius would be the radius at 2. Radius at 2. But remember, this is volume, so that's the radius squared. Plus the radius at 4 squared, plus the radius at 6 squared, plus the radius at 8 squared. 2 pi then times radius at 2 squared. What's the radius at 2? 4 squared is 16. Radius at 4 is 3 squared is 9. Radius at 6 is 2, and squared is 4. And the radius at 8 is 3, and squared is 9. Altogether, then, my estimate is the sum inside 25, 29, 38 minus 2 pi. 76 pi. Now let's actually include the units here. What are the units here? Inches? Inches? Cubed. Okay. All right. Now, would that be an overestimate or an underestimate? Or can't tell? Can't exactly tell. Right rectangles overestimate an increasing function, but are these all increasing? No. So there's a bit of a mixed bag there, so we can't really tell. All right. We could, however, get a better and better volume if, instead of the height and the radius at 5 points, we had the radius and height at infinitely many points, which I was kind enough to find for you. Using regression, I could find data through 5 points. I could get an equation through 5 points, perfectly hit everyone by a 4th degree equation. So I did worked at regression, and this equation rounded, it's rounded values, but goes through all 4 of those points. Now, that means then that instead of these 4 cylinders, I can calculate tons of cylinders. Think of a lot of quarters stacked in there, or a lot of different size cylinders stacked in there to perfectly fit, wedge in each time. Now I can add tons and tons and tons of cylinders via calculus. So what's my setup then? Volume is pi. Integral to add infinitely many. From where to where? 0 to 8. Pi r squared h. Okay. Now, bypass the r squared for a second and let's go to the h. What's the h of each of these cylinders? dh. Okay, it's a tiny change in h each time we're going up. It's tempting to say y because, you know, it's vertical and all that. There's no y here. It's r and h. All right, so what's the radius? R of h, yeah. It's different, it varies as a function of h, and we have it as a function of h because it's a function of h. We're good, it matches the variable integration. You slap that into your calculator, which, in the interest of time, let's just assume you can do that well, and you get your perfect button. So, let's see. Just a quick check to make sure you understand. What do you call it, just vocabulary-wise, what do you call it when you revolve a region around an axis? A cylinder is made by the rectangle, but the whole figure is called the solid of revolution. You're one step ahead of me. Okay? When you revolve a rectangle around an axis of revolution, you get a cylinder. And that's the way we are going to get the volume. To find the volume of the solid, we add infinitely many, infinitely thin cylinders. With pi r squared h, where the h is d something. Okay? And remember, when you're sketching, the slice is perpendicular to the axis of revolution. I don't ask that it's beautiful, I just ask that you try. All right? I do require a sketch. In the homework, I thought the hardest problems were at the back side, so I want to start at the back side. Please go to the back page. Oh, sorry, my bad. We went over the very last problem already. That was how we started the class. So, looking at 26, my answer was 4 over pi. Do you concur? Okay, if you did not get 4 over pi, this is the integral I used, the area from 0 to 2, and I had a u sub of pi x over 4. It was a function within a function, so u sub it. 25. 25, x equals 4 minus y squared looks like this. When it's function of y, then you're using y as the variable of integration. The bases are all just whatever the curve is. And they're all going to be positive because these are all positive x values. And the height is dy high from -2 to 2. That's 32/3. Check your work here. X times x minus 4. That parabola is below the axis. You should never get negative area. If it says find the area, then it needs to be positive. You don't get positive area by just saying, I'll just change my answer again. You make it positive by saying, well, these heights are negative heights, so you take the opposite to make the heights positive. And the volume then is, or the area rather, is 32/3. Again. Okay? They should never be negative. 23 absolutely kicked my butt. But the answer I eventually found is 162 off. If you got that, then you are the chimp, because that was, if they were putting little physics dots, this is the hardest. One dot, 2 dots, 3 dots for the hardest. This is a 3-dotter, baby. This one's difficult. The idea goes something like this. In this cross section, there's fluid flowing through this. Okay? Depending on how far out from the center you are, I don't know if it's because of in terms of viscosity or what, but water flows more quickly through the center than it does towards the outside. Right? So the rate it flows through here is going to vary based on R. So I will actually need to find how much volume goes through each of those points. I'll have to talk about the rate, 9 minus R squared, but then times how much region is there. Now that's the hard part. How do I find that? So I'm looking for the rate, the volume rate. Okay. Now it has to do with, first of all, how fast it goes through, but then how much area. How do I find, back to that question that I just asked, how do I find the area of that black ring? We talked about population density a little like this last year. 2 pi r, yeah. It's more like if you straighten that out, the circumference would be that. And what's this? That would be like the thickness of the ring. And it's super thin. What do you call it? Super thin? Change out from the ring, from the center. d r. Okay? Now you would take the rate at which it passes through times how much area there is to pass through. I think you'll also agree that the more area there is to pass through, the more volume is going to pass through that. If I then add all those different volume calculations, then that will give me an overall volume rate. Check the units here. What are the units on this rate it goes through at any point? Centimeters per second. What is the rate here? Or what are the units there? Excuse me. Centimeters and centimeters, so that's square centimeters. So overall then, this is going to be a rate at which the volume of water passes through over any time frame, right? So if I talk about, now let's talk a little more details. The limits of integration, what are they? 0 to 3, 0 to 4. I can see an argument for 0 to 3 because it's about the radius. I can see 0 to 4 because it's 4 seconds. Which one? 0 to 3, why? Because it's the radius. You want the bounds for the radius, 0 to 3. I thought for a minute this morning, do I need negative 3 to 3? But 0 to 3 covers all the rings. From going 0 to 3, it covers all rings. All right? Now, that then integrated is some big mess. It's a number. Okay? Whatever that is. And then I stopped and I think, okay, where's my answer? But then I didn't read all the question. This is a rate, a volume rate. But they don't ask the volume rate. They say, what's the total volume that flows through in 4 seconds? Well, if it's this rate, cubic centimeters per second, then I need to multiply that by that many cubic centimeters per second times how many seconds? Times 4 seconds. And in that 4 seconds, we'll get 162.5. That's a challenge problem, and I just want you to think about it, okay? Actually, this is a multi-part problem, so we better start from the beginning here. So from this fundamental theorem kind of problem, you see our map, people? The integral from 0 to 1, I don't like 0 to 1, so I inverted it and called it negative. Then I said, all right, that region is a quarter circle above the axis, so I got negative pi over 4. Okay? B was a little funky, felt like a little bit of a trick question. For what values does G prime fail to exist? What's the relationship between G and F, or G prime and F? G prime is F, okay? Well, look at the graph. That's F. Does F fail to exist anywhere? Okay, fail to exist would be like there's a hole or an asymptote. Is there any such point there? But it's a sharp turn, but that doesn't keep F from existing. That keeps F prime from existing. And that'll be a problem in a second. But in terms of F, the graph is smooth. It's continuous. It exists everywhere. Okay? G prime, which equals F, exists at all points. There is no hole, no asymptote, no problem with the graph. It's continuous. It's defined for all values in 0 to 10. Now the harder part by far is the second part. This is a pretty rare, like 1 every 4 years kind of free response question where you have to prove, not state, prove a derivative doesn't exist. It's a little tricky. So try to get you some practice just in case it shows up this year. If you were to show G double fails to exist at 2 and 4, then the very first thing you must do is connect G double to F prime. G double is F prime. That's easy. So far, so good? Now, we know that the derivative doesn't exist at places where there's a vertical tangent or a sharp turn, but that's not justification. You can't say it doesn't exist because of this sharp turn. You have to prove it using the definition of the derivative. And hopefully then yesterday's homework helped us a little. If I did the derivative at 2, then I'd be talking what do the slopes between 2 and some other point approach. If I wrote an equation for that, wouldn't that be f of x minus f at 2 over x minus 2 as the slope between those 2 points? alternate definition, okay? And to get them closer and closer together, I take x towards 2. What are these slopes? If I drew these, they would start to look like that. What do those numbers approach? Here, if I were to say, look at this slope, maybe -1, -2, -3, -4, -500, -5 million. What do those slopes approach? Infinity, positive or negative? They approach negative infinity from both sides. Now that said then, that's the limit doesn't exist. There is no numerical slope. Limit doesn't exist. So f prime at 2
Good morning, Evelyn Gadwire. Please rise
doesn't
for the Pledge
exist.
of Allegiance. Ready? Begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
I'll do a little writing up here that I want to talk about.
All 11th graders will be required to complete ICAP tests today during 7th hour. Last name.
It's a little different at 4 because the slopes are different on each side.
Thank you for your cooperation.
All students except those in ICAP tasks, please report to your fourth period class during 7th hour.
For students grading 7 through
If I
11,
take a point over here and connect it to
during
4,
the summer of
Yes.
2019, or sign up with your history teacher for upcoming information or stop by to see Ms. Holden, W205.
Don't forget to clear your exploration today in the library.
Oh.
During both parts.
yes,
For exploration into the
I was supposed to read
environment
6.
clear.
You're right. Sorry, 4 is fine, the derivative is 0 there, I'm sorry, I'm stupid. It meant to be 6.
We will talk about life as an
Thank you.
aerospace engineer. Hope to see
So
you
that's
there.
x equals 6.
January 15th is the
Okay.
application deadline for CU.
If you take a point left in there, those slopes, what do they
If you
approach?
haven't already requested that in Naviance, please request it.
Positive infinity here or negative infinity as I go
Don't let
closer?
those dates slip by.
Positive infinity. Now that actually right there
National Junior Honor Society will be in the
is enough to say D and E, but what do they approach from the right?
Roll silent calculate, please bring your money. Please don't let your
If I use an x over here, what are these slopes? Yeah, they're 1.
Yeah. Congratulations to boys varsity and JV for their win against Sweet Race last night, and congrats to L3 for their big win against Evergreen last week. Go
So you
Jags.
could also say no one's left
Let's
or
pass
right
the
hand,
jungle
don't
and let
breathe
your
it.
team and the boys take on Valor tomorrow. And the girls. Boys play 7 and girls at 5:30. Team talk,
6, I
let's
keep
talk.
using
Don't-
4, sorry, 6.
If you want a front parking spot, so you don't have to walk in this frigid cold every morning, then come to the doubleheader against Valor tomorrow. If you're a senior student driver, pick up a free ticket for the drawing at
6,
the
okay?
entrance to the gym to enter the contest. Tickets will only be available
Um,
during the first 3 quarters of the girls' game starting at 5:30, and only one will be given per person. At halftime,
That
before
one's
the game, the
pretty
winner will
old.
be announced in the-
I might give you a hint on D, on E.
Senior student drivers only. The students
Look
in
at your
all grades
results at D.
join for other special prizes. That's all your announcement. Have a great day.
In D, I found that G at 0 was negative pi over 4, and G at 2 was positive pi over 4. G prime, or G, which equals, G prime, which equals F, is positive that whole region, so it's got to be increasing that whole time. So doesn't it have to pass through 0 when it goes from negative pi over 4 to pi over 4? So that's one time, once by IVT in 0 to 2. Then later it goes from, when it goes from 2 to 6, it goes from pi over 4 down to negative 7 pi over 4. You can't go from pi over 4 to negative 7 pi over 4 unless G equals 0 once in 2 to 6. Again, it is continuous. G is continuous. And finally, G at 10 was something ugly, but definitely positive. And so surely G equals 0 once in 6 to 10. So the conclusion was it must pass through 0 3 times. And you could establish that by IVT and using the points you found in part B. Okay, I'm probably not going to get through the rest. This is what I will post my key at lunch if you want to go over everything on the first 2 pages. But I want this turned in by the end of the day just to see that you did it. Do you want a couple more answers before yours? It's 9? Sure. 9 I split it up this way. It's 2 integrals. X over x squared plus 1, 2 over x squared plus 1. This is u sub. In fact, it was done in number 8. And this is arctangent. Okay. Anything else you would like to real quick shout out? This is 9. She has to have 9.
Number 9 had x plus 2.
Yes. So you're separated it into 2.
Oh,
I see. Yeah. Okay. All right, get this to me by the end of the day, please. Have a great day.
Mr.
Yes.
Between on the key that's up there, how do you know that there's a 0 between 6 and 10?
This is negative and this is positive, so it must pass through 0. Now, my work actually had quite a bit more. You really, to do this well, you have to say it's monotonic, so, or is strictly increasing, so you know it'll be done through once rather than repeating times. So that, in good work, which is that you know, you should probably say that.
For 23,
Yeah.
I just get lucky because I took the integral of r and then I did my math from 0 to 1. But when I changed it,
What did you, you're welcome, have a good day. What did you integrate with respect to?
I was just looking at the units, but then I got centimeters here. This is
So let me,
centimeters.
so if you're anything with this, with respect to R, the area, let's go.
But then I took volume. Just because I didn't do anything with the first section.
Yeah. Yeah. Because this actually would be the volume, this is like a probably easy to work.
What?
This, that gives you
Okay. I was just wondering.
Yeah.
Cool. Thanks.
Yeah, you bet. Okay. Have a nice day. All right.
Oh, Mr.
Yes.
You have set 72.
I do.
I would like to commandeer a copy of one.
Okay. I have the notes, and I have to put that up to you if you choose to be. Tomorrow's lesson is pretty. And I'm not going to follow You're welcome. Have a good day. Peace, Waller.
What?
Peace.
Oh, they said please. I'm like, I'm not even doing anything. Thank you.
Thank you. Oh, sorry, I forgot to stop recording.